So in this video, we're going to demonstrate dividing using the Roman abacus and the Roman counting board. And we're going to use some of the techniques we've been using in the Reading Ancient Schoolroom. This video presupposes the information in our video called Introduction to the Roman Abacus and Counting Board, so you might like to watch that video first. Now, to do division, we're going to use two counting boards, or we could use two abacuses, but I'm going to start with two counting boards. We've got one here from the Roma shop, and we've got one here that we've made by scratching on a wax tablet. They've both got big rectangles for ones, tens, hundreds and thousands, and then on this one we've added an extra big rectangle for 10,000s because in a bit we're going to use that. And up here we've got little squares for 5s, 50s, 500s, 5,000s, and here an extra little square for 50,000s. To show how we're going to do division on two counting boards, I'm going to start with a really easy sum and do that one in slow motion. I'm going to start with 24 divided by 2. Imagine you haven't just done it in your head so that we can see how it works on two counting boards. Now I'm going to start by entering 24 onto counting board number 1. That's XX, I, and then I'm going to go as far to the left of the 24 as I can and find something that's easy to divide by 2. And what I mean for this purpose by something that's easy to divide by 2 is something that looks like a 2 on the counting board. If we think about what a 2 looks like this on the counting board. It's two counters together in the same space. Looking on this counting board, I can find two counters together in the same space. Here, Eleanor, if I focus on just those two counters, what number do they make?
20.
And what's 20 divided by 2?
10.
Good, that's 10. And what I'm going to do is I'm going to remove those 20 and add a counter here for 10, because what I'm doing on counting board number 2 is building up my answer. So that's a contribution to our answer. And what I've got here is the part of my original number that I haven't yet divided by 2. And now I'm going to repeat the same procedure. I'm going to look as far to the left as I can. I can't get very far to the left this time, but I can again find two counters together in the same space. And what do just those two come to?
2.
And what's 2 divided by 2?
1.
Good, so I'm going to remove those and contribute this time a 1 to my answer. And then I'm left with one more lot of just 2, and again, 2 divided by 2 is 1, so remove those and add a 1 to our answer, and that's the answer to our question, and of course it's 12. Now let's do a slightly harder one. Let's do 2,331 divided by 21. Eleanor, could you write 2,331 and 21 on your wax tablet? We've been finding in the Reading Ancient Schoolroom that it's quite useful to have a written record of the sum that we're doing, the number that we want to divide by another number and the number we're dividing it by, because if we get to the end and we can't remember what the sum was, it's hard to know if we got the answer right. And if you're the teacher and you give an exercise to a pupil and the pupil goes off and does it, meanwhile you're explaining something else to a different pupil, pupil number 1 comes back with the answer and you can't remember what the question was, it's very hard to know what feedback to give your pupil. Good, so we're going to do 2,331 divided by 21. I'm going to start by entering 2,331 on counting board number 1, and we're going to start as far to the left as possible, and this time we're going to find sets of counters that make the shape of a 21. Thinking about what a 21 looks like, we don't really want a 21 on this counting board, I'm just using it to think for a moment. 21 looks like this. Two counters in the same space as each other, and then one in the space to the right of them. Eleanor, as far to the left as you can you find counters in that configuration?
So here we've got 2, and here we've got 3, but if we ignore those and just take this one, we have that.
Good, and what number do just those 3 counters make?
2,100.
And if you divide that by 21, what do you get?
100.
Good, so we want to remove those 3 counters and contribute 100 to our answer. where we think what that number actually is in our numbers. If we go back to our original number there, we're going to remove those 3 counters. One way of thinking about this on the Roman counting board is that number we're going to remove, it looks like a 21, but it's shifted 2 places to the left. 21 divided by 21 would be 1. 21 shifted 2 places to the left is going to be the same thing as 21 divided by 21, that's 1, but again, shifted 2 places to the left. So that number divided by 21 is going to be C, or 100. Now, Eleanor, can you repeat the same procedure and remove some counters that make the shape of a 21?
So I could take these 2 hundreds and the 10.
And when you take those away, what do you need to contribute to your answer?
10.
And then, can you repeat the same procedure again?
So that was a 21 itself, and therefore I'm contributing 1.
Excellent, because 21 divided by 21 is 1. And that's your answer, and what number is that?
111.
Excellent, good. Now let's do a harder one. And in fact, we thought we could do 38,692 divided by 215. We thought we might do this one because in the early 20th century, a scholar called Rudolf Beigel wrote a book on Roman reckoning and bookkeeping, in which there's a footnote where he says he's got a letter from Moritz Cantor, the historian of mathematics, in which Cantor says that he doubts that an ordinary Roman, even a quite well-to-do one with a good education, would have dared to do that particular sum. So we thought we could take this one as a bit of a challenge. Now, Eleanor has written 38,692 and 215 on a piece of papyrus. Romans might have written on various things. If they had a piece of papyrus, they might have used it. They probably wouldn't have used a nice new piece of papyrus like this one, but this is what we've got. This is, of course, not an ancient piece of papyrus, or we wouldn't be writing on it. It's a new piece of papyrus from a piece of modern papyrus from the Roma shop. Good, so we're going to start by entering 38,692 on counting board number 1. That's the 30,000, that's what we needed this column for, and then we want 8,000, and then 692. And now we're going to start removing sets of counters that look like a 215. Thinking about, for a moment, what 215 looks like, that's 2 counters together, and then 1 in the space to the right of them, and then 1 diagonally up to the right again. So we're going to remove counters in that configuration, starting with 2 of those, 1 of those, and 1 of those. The number I've just removed looks like 215, but it's all shifted 2 places to the left. That means that number was 215 times 100, divided by 215, and I get 100 to contribute to my answer. Now, I can't remove another lot of 2 of those, 1 of those, and 1 of those, because I haven't got a big enough number left on the counting board, but I can remove 2 of those, 1 of those, and 1 of those, and that was now 215 times 10, so I need to contribute 10 to my answer. I can now remove another lot of that number, but it's going to be a little bit more challenging because I haven't got, for example, 2 beads there, but I can remember that removing 2 thousands is the same as removing 5 thousands and adding 3 thousands, and then removing 100 is the same as removing 1,000 and adding 900, and then removing 50 is the same as removing 100 and adding 50, and that will contribute another 10 to my answer. And then I can remove another 2 of those, 1 of those, and 1 of those. That will contribute another 10 to my answer. I can then remove another 2 of those if I remember that removing 2 thousands is the same as removing 10 thousands and adding 8 thousands, and then I can remove 100 and remove another 50 by taking it from the 100. That contributes another 10 to my answer. I can then remove another 2 thousands, 100 by taking it from the 500, and 50, and that contributes another 10 to my answer. I don't really want more than 4 counters in one of those big rectangles, but adding a 5th one would get me to 5 tens. That would be 50, and then I can remove another 2,000, that's 1,000, and the other one I'm going to take from the 5,000 and then 100 and then 50 like that. That contributes another 10 to my answer, and then another 2,150, that contributes another 10. And now I haven't got a big enough number left to remove any more lots of 2,150, but I can remove some lots of 215 itself. I can remove 200 by starting with 100 and then taking a second 100 from one of the thousands, and then 10 and then 5 by subtracting 10 and adding 5. That now contributes a 1 to my answer. I can then take away another 2 of those, 1 of those and 1 of those. That was another 215 itself. I can remove another lot of 215. This one's going to be slightly more tricky. 2 of those, 1 of those, and now I want to remove 5, and I'm actually going to have to take it away from the 500. Taking away 5 is the same as taking away 500 and adding 495. And that was another 215 itself I removed. I can then take away another 215 and add another one there, and then another 215, 210 and 5 like that, and adding another one there would get me to 5 up here, and then I can remove another 200. I have to take them away from the 1,000 and then a 10 and a 5, and I add another one to the answer, and then another 210 by taking 10 away from 50, and then 5 by taking it away from 10. That's another one in the answer, and then another 200, that's 100, and that's the second 100, and 10 and 5, that's another one in the answer, and then I can remove another 210 and 5, and that's another one in the answer, and the number I'm left with there is now smaller than 215, that's 207. So there's no way I can get another lot of 215 out of that. So our answer is 179 remainder 207. Now there are various things we could do with this remainder. Romans sometimes used fractions, and we could worry about how to convert 207 over 215 into a fraction that Romans would have liked to use. We're not going to do that in this video. We might do that in another video. But Romans sometimes did an approximation. 207 is not too much less than 215. And one thing they might have done is say, well, this is almost another lot of 215. So our answer is roughly 180. Or they might have said it's 179 plus something left over. Now, we wrote down the sum we were doing. We didn't write down any intermediate workings. And I think that's quite nice, because we have examples of texts where Romans mention a sum that they did and the answer that they got. So we know that they sometimes wrote down sums that they were doing and wrote down their answers. We don't have any example of Romans writing down intermediate workings. We don't have any surviving written intermediate workings. And quite possibly that's because Romans didn't do their intermediate workings in writing. Of course, it's possible they did and they don't survive. But it's nice that we haven't had to do that. But on the other hand, we have been using 2 counting boards. And using 2 counting boards does something of the same job as writing down intermediate workings. And we actually haven't got any evidence, as far as I know, of Romans using 2 counting boards or 2 abacuses at the same time. Maybe they did, but I've been asking myself if there would be a way of doing the same sum with just 1 counting board or just 1 abacus. And I think there is, if we take a bit of inspiration from one of the ways of dividing on the Japanese soroban or the Japanese abacus. I'm going to demonstrate this one now on the abacus. The Japanese soroban in its modern form has essentially the same structure as a Roman abacus. If we forget about those two columns on the right that were used for Roman fractions, and if we start with this column and then go over to the left. At the bottom we've got long grooves with 4 beads each, and at the top we've got short grooves with 1 bead each. And that's the same on a Japanese soroban, but what we don't have on the soroban is these numerals written in the middle. And that allows one to be more flexible on the soroban by defining the values of various columns in different ways depending on the calculation that you're doing. And one thing it allows you to do when you're doing division is to define a particular space towards the left of the abacus as if it were effectively a second abacus in which you're building up your answer. And I thought we could see if we can do a version of that for the sum that we've been doing using just one Roman abacus. So I'm going to start in the same way by entering 38,692 in the normal way. So that's the 30,000 and then 8,692. And then I want to remove sets of counters that look like 215. And I can start with 2 of those, 1 of those, and 1 of those. And having removed those, what I've just removed was 215 times 100, or 215 shifted 2 places to the left. I want to contribute 100 to my answer. Now suppose I define this spare column all the way on the left as a hundreds column and add 100 to my answer like that. I'm going to have to think away this numeral that says 1,000,000, because I'm not actually using this as a millions column. I'm using this now as a hundreds column. In due course, I'm going to use this one as a tens column. So again, I need to think away that 100,000 in there. And I also need to remember that at least for now, it's only those 2 columns all the way on the left that are part of this, as it were, second abacus where I'm building up the answer. This column is still part of the number I'm trying to divide by 215. Now the next lot of beads I can remove are going to be 2 of those, 1 of those, and 1 of those, and that's going to account for a 10 in my answer. The answer I'm building up is now dangerously close to the start of the number I'm trying to divide. I need to remember that this third column again belongs to the number I'm trying to divide, because I haven't yet dealt with that bead. Now I can remove another 2 of those by remembering that 2 of those equals removing 1 of those and adding 3 of those, and then I can remove 1 of those by removing 1 of those and adding 9 of those, and then I can remove a 50 by removing 100 and adding 50. That's going to account for another 10 in my answer. I can then remove another 2 of those, 1 of those, and 1 of those, add another 10 to my answer. I can now remove another 2 of those by removing 1 of those and adding 8 of those, and then 1 of those and 1 of those like that. That's going to account for another 10 in my answer. And notice that this third column has now been freed up. So when I need it, I'm going to be able to use that one as a ones column, but in the answer. But I still need to remember that now from column number 4 onwards is still part of the number that I'm dividing by 215. Now I can do another lot of 2 of those, 1 of those in that way, and 1 of those. That will account for another 10 in my answer. That will get me to 1 of those, and then I can do another 2 of these. That's 1, and that's the other one, and then 1 of those, and then 1 of those in that way. That gets me to another 10 in the answer, and then another 2 of those, 1 of those, and 1 of those. That gets me to another 10 in the answer. And now I haven't got a big enough number left that I can do any more lots of 2 of those, 1 of those, and 1 of those, but I can still remove some lots of 215 itself. There's 100, there's a second 100, there's 10, and then the 5 like that. I now need to contribute a 1 to my answer, and again remember that this bead does not belong to the answer, this still belongs to the question. And now I can remove another lot of 200 plus 10 plus 5, that's another 1 over there, and then another lot of 210, and this is where it gets slightly tricky. I want to remove 5, but I'm going to have to remove them from the 500 like that. That's another 1 in my answer, and then another lot of 2, 1, and 1 like that. This bead sticks, so I'm going to move it carefully, and then 2, 1, and one of those like that, and another one of those will get me to 5 up there, and then I can remove another 200, taking them away from the 1,000, and then 10 and then 5. That's another one in the answer, and then another 200, 10 and 5. It's another one over there, and then another 200. That's 1, that's 2, 10 and 5. That's another one in the answer, and then another 200, 10 and 5, and that's the sticky bead, another 10, another one in the answer, and the answer now is once again 179, remainder 207. So it's possible to do this using just one Roman abacus. I don't have any proof that Romans did this, but it's interesting to know that it's possible. That brings us to the end of this video. This is who we are. Thank you very much for watching.